In the last lecture on marketing analytics, we have seen uh, conjoint analysis. Conjoint means considered jointly. Whenever we think of any product or the service, there are many features in that product, and each feature has got different specifications. Different customer have liking for different liking for those specifications of various features. In conjoint analysis, we collect the rating for different features given by the customer who are going to use the product or service. And then we carry out the regression analysis on the data collected, and we get the relative values assigned to each specification in the regression equation. That regression equation is then utilized for taking various decisions like what should be the price kept, and if this particular combination of feature is joined together, then what is going to be utility of that particular product, or what is how much that should be priced for customer, so that it gives benefit to the organization, right? Now the second opportunity of learning analytics in marketing is by means of segmentation analytics and choosing target segments. You have learned well about segmentation in marketing management. So I won't be taking the different philosophies of segmentation, because you have seen that enough in marketing management. I'll be touching a bit to that, and then we will be seeing how the analytics helps in doing the segmentation, right? So we will be learning market segmentation analytics by means of a case. Urban Bites, it is a fast casual dining expansion. Mm, Urban Bite is a mid-sized fast casual restaurant chain operating in five major cities in India. They serve healthy, customizable meals at mid-range price. After 4 years of consistent growth, they plan to expand into two new cities. However, management is unsure which customer segment to focus on in the new market. They want to use data driven analytics to identify segment and target customers effectively. So, the data available uh, is the company has conducted market research in one of the target cities and collected survey plus behavioral data. The data which I'll be presenting to you in this video is a hypothetical data set. The variable included in that data set, like you also in some other case will be collecting the data pertaining to demographic like age, income, occupation, family status, and so few more things. In this particular case, we have collected the data pertaining to age, income, occupation, family status, right? Then psychographics data, health consciousness score, time sensitivity, then price sensitivity score, some behavioral data like frequency of dining out, preferred cuisine type, average spending per meal, use of food delivery apps, right? This is all the data which is very proper to be collected whenever you are thinking of some restaurant expansion, right? Then lastly, attitudinal data. importance to convenience, importance to taste, importance to ambience, and sustainability, right? So all the data we have collected is given in the table having headers like age, income, occupation, so on up till importance to ambience and importance to sustainability. This case teaches analytics driven segmentation. We will be focusing, even though we are collecting the data pertaining to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 fields, but we will be dealing with only quantitative information for clustering, right? Because the k-means clustering will be done conveniently on the quantitative data. If you have categorical variables, then it is possible to convert that to quantitative data like 1 or 0. If you convert the categorical data columns into multiple columns, suppose say there are if some value for importance to taste is 1 2 3, then you can convert this importance to taste column, importance to taste 1, importance to taste 2, and importance to taste 3, like we have seen in conjoint analysis case, right? So we in this lecture we will be limiting ourselves to quantitative data only. So there are 10 fields which deal with quantitative information like age, income, then health consciousness, time sensitivity, price sensitivity. There are few more you will be seeing later in this lecture, right? Then analytics driven targeting, that is market attractiveness versus competitive fit framework, right? I'll be showing you urban segmentation data which we have collected, and then we will be doing K means cluster analysis, because cluster means it is forming different groups, and segmentation is also forming different groups. The purpose of um, uh, both the thing is same. Only cluster analytics is analytics side thing, and segmentation is a marketing side thing. So we will be clubbing both this. We'll be using segmentation related information, and we will be running cluster analysis to help us form different clusters, and that those clusters which are formed will be calling them as the segment, right? Otherwise the segment market segmentation, customer segmentation is done subjectively by collecting by forming the groups of common specification information for various features, right? So there is some very popular algorithm in clustering, that is K means clustering. Okay, it is very easy. We will be seeing that clustering algorithm as we go along in this lecture. But before that, we will be seeing the data which we have collected, urban segmentation, right? Urban byte segmentation. This is the data I will be showing you, right? You have we have collected the data for something like 200, 200 customers, right? We have collected their age, income, occupation, then family status. Under these are family status are categorical. Occupation is also categorical. Then health consciousness, we have converted it to numbers by though it is categorical, but we have converted it to numbers by giving the obtaining the score between 1 to 10. Similar way, time sensitivity again, that categorical variable we have converted to numerical by collecting the weights between 1 to 10. Similar way, price sensitivity. Okay, 10 means higher sensitivity, 1 means lower sensitivity. Same thing about time, sensitivity, health consciousness. Then dining frequency we have collected, like the values which you are seeing on the screen will be helping you to know the type of data we have collected under dining frequency. Low means less than 2 per month, medium means 2 to 6 per month, and high means greater than 6 per month. Like average spending, this is in rupees, 800, so on. Then food app usage. Again, it is categorical: high, medium, low, in three categories mostly. Then importance, how much importance that the customer give to convenience. That is again a score given from 1 to 10. Importance to taste, again the score given from 1 to taste. Importance to ambience, again score from 1 to 10. And importance to sustainability, again the score from 1 to 10. So we have collected the data in 14 columns, right? And then in the same sheet we have performed and the k means clustering analysis, right? Now what I have done, I'll be showing you so that you understand the things better. Okay, right? So here I have mentioned some column headers, means column headers as far as not headers actually. This column alphabet, column reference alphabets like A B C D E F G S, so on. So age is there in B column. This will help me in applying the formula in Excel, right? So B to O columns are there, not exactly B to O, B, C, F. Like again, I'll help you see that. B is for age, C is for income, F is for health consciousness, then G is for time sensitivity, H price sensitivity, then you have average spending in J column, then in L column, M column, N and O column, you have importance to convenience, importance to taste, importance to ambience, and importance to sustainability. So those alphabets I have given here, and I have numbered them as to the 2, 3, 4, 5, 6. Just these numbers. The purpose of this number I will not explain to you in this video lecture, but just I'll be saying to you that these numbers I'll be using in the formula to help me refer to a particular thing in this column, right? So that is not the stuff to be explained, but it is the stuff to be understood later whenever you will be referring to this Excel sheet, right? Right here, I'll be explaining the thing in various blocks whereby you understand K means clustering. Okay, Excel, how its Excel implementation can be understood later, if and that can be understood by the students who are interested in it. I'll be providing you the Excel sheet. From that Excel sheet you can understand the things yourself, or I can help you if you do not understand this thing, Excel implementation. If you do not understand this thing, I can explain you specifically later. Anyway, so you just understand this 2, 3, 4 are the numbers, so as to be able to refer to these values in the formulas, formulae which we will be seeing ahead. So whenever you have data, there should be the tendency to find the mean and standard deviation, mu sigma. and also the maximum value and minimum value, so that you can do something on some processing on the column, right? For example, age, by looking at age column, you will be you it is possible for you to find the average and the standard deviation by using the formula from Excel. For average, for mean, it is equal to average, and you give the range. For standard deviation, you use the formula is equal to STDEV. In bracket, you give the range. It will be finding for you the mean and standard deviation. I am not going to use mean and standard deviation in the K-mean clustering algorithm, but there are some cases wherein mu and sigma is used for converting your data to some different values and some kind of mapping. But in the K-mean clustering algorithm I'll be using, I will be converting the data which I am having here. This data I'll be converting to the values between 0 to 1. I'll be mapping everything to the values between 0 to 1, because you see the age will be ranging from 20 to 40 or 50. Income may be ranging from 20,000 or 10,000 to something near around 1 lakh or 1 lakh 50,000 per month. Okay, so the actual range I have here, I have found out maximum value and minimum value. So the age ranges from 20 to 44, income ranges from 20,000 to 1,000, and health consciousness score ranges from 1 to 10, and so on. Okay, what I am going to do with this range, minimum maximum value, I will be considering 20 as 0, 44 as 1, and values in between I will be accordingly mapping. For example, the range is 20 to 24 is the range of 24, 20 to 44 is the range of 24. So midpoint of 20 to 44 is going to be something like 34, not 34, 32. Okay, let me calculate. This is 24 plus 20 plus half of that 24 is 12. 20 plus 12, 32 is the midpoint. So at midpoint, if 20 I consider as 0 and 44 as 1, then the midpoint, which is 32, will be considered as zero point 0.5. So every value between 20 to 44, I'll be converting to 0 to 1. I can easily do that by using the formula or the equation of line. Equation of line means what? A 20, 0 is one coordinate, and 44 1 is another coordinate. You can find the equation of line, and with that equation of line, for every value of age you have, putting the value in that equation, line equation formula, you will be getting the value mapped between 0 to 1. That you can do here too. So you just look here, all the values, all the data, which I had collected. Different columns have different ranges, but I have converted all the data to range between 0 to 1. Okay, this is age, this is income, and then health consciousness score mapped between. This was uh, age, this was what income, this was health consciousness score, means all the values in 10 columns, like from B to O, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In 10 columns, the data which was there in different ranges, I have converted it to a range, converted to value between 0 to 1 by using very simple formula, that is value there minus minimum value divided by maximum minus minimum. You can use this formula, x minus minimum, right here, x minus minimum. Just a minute, let me understand. Hmm. X minus minimum upon maximum minus minimum. Maximum minus minimum means range length. Okay, so x minus minimum, the value which you want to convert, say, is x. You subtract it from that minimum value divided by difference between maximum and minimum will get you the value converted to range between 0 and 1. So you have converted all the values in between 0 and 1. Now, for carrying out K means clustering, what we do, from this 200 uh, data points, 200 records, I'll be randomly selecting three cluster centers. I'll be selecting three records randomly. For example, I have selected, say, by using random number or some figure I'll get in my mind. So I have selected one record as 134, another record 94th record. Means how do I do that? Just 134th record I'll be getting here, means from here. Just look at here. I'll be going to 134 number. These random numbers I have taken 134. Okay, so look at this, 134. This gray highlighted is 134th record. So I'll be taking all these 10 values and in the 134th record. Okay, this I'll be calling as cluster center 1. Okay, similar way, I will be taking cluster center 2, where, just look here, I will be taking three centers. Just to make you understand the thing, I'll be taking three centers, right? From this data, I have taken first center as this set of 10 values from this one. Then from the data which I have mapped, from the data frame which I have mapped between 0 to 1. Alright, then I will be taking 94th record, right? 94th record, and then I'll be taking 153rd record. All the values I'll be taking from this table which I have created, mapped between 0 to 1, right? So all those values for my ready reference, the 10 values from that table. Okay, for making you understand, I'll be giving it a color so that I can refer to that color and you will understand which table I am talking about, right? So let me do that kind of work of giving the data a color. These are 200 records which I am coloring. Uh, which I am coloring to some color like this one, green. Okay, it's too dark for you. Let me see. No, it is going to be a bit dark. We'll be making it lighter. Hmm. to light. This is okay. Okay. So this is the data which I have converted from original data to have the values between 0 to 1 in this green table, light green table. From this table, I have taken three records, okay, randomly three records. Which three? 134th record, 94th record, and 153rd record. Okay, all those 10 values I have means 10 values in the record. Each record is having 10 values. Those 10 values I am writing here, and this I will be coloring to something different. Like these are my centers selected from this green table at these numbers. Okay, it's not necessary that you will also be selecting the records from this green table at these numbers 134, 94, and 153. No, you may select, you randomly select some number like 117, then 63, and then 22. That will do. I'll be calling this as cluster centers. Okay, this the cluster center has 10 coordinates. Like when we think of certain point in the graph paper, it will have two coordinates. But now I have to my center C1 10 coordinates, 10 values. Okay, 1, 2, 3, 4 up till 10. Each center is having 10 values. Now, what I will be doing from each center, I will be finding the distance of each point. Okay, I will be finding the distance of point 1, record 1 from C3 to AG3. I'll be finding the distance of this point, record number 1 from center number 1. Now, how to find the distance? For that, we'll be going once again to the transparency, right? Mhm. Just look here. Suppose say you have this as a center indicated by coordinate values like C1, C2, C3, C4, so on up till C10. And you are having this as a record from your light green table, first record for example, and you are taking the coordinate from that table as x1, x2, x3, x4, so on up till x10. Now the distance of this point from this center will be given by C1 minus x1 square plus C2 minus x2 square plus C3 minus x3 square plus C4 minus x4 square, so on up till C10 minus x10 square. This is the square of the distance actually. This is called as Euclidean distance. I am mentioning it as this square, and suppose say you want the distance, then you will be taking the square root of this sum, right? I'll not be taking square root of any distance anywhere. I am okay with sum of the sum of the squares of difference between x1 c1, x2 c2, x3 c3, so on up till x10 c10. This is Euclidean distance. So I will be finding the distance of this point from this center. Then I have another center too. I'll be finding the distance of this point from another center, second center, and then I have third center here, randomly taken. Okay, I'll be finding the distance of this point, this record from the third center. I'll be getting three distances of this point from three centers. Okay, I am now once again going back to the Excel sheet. Okay, so for first point, for your reference, I will be writing the record number here. All right. So our first point means all these 10 points from this 10 points, 10 coordinates. I'll be finding the distance. For example, just coming 0.25 minus 0.875 square, then second value 0.25 minus 0.5 square, then third one, just for illustration, 1 minus 0.55556 square, and so on up till last value, which is going to be 0.55556, sorry, minus 1 square, right? That is going to give me the distance, and that distance I am writing here. Okay. Then from second center, this is second center, again I'll be finding the distance of the first point, that is written here. Then from the third center, which is signified by third row of the first point, I'll be finding the distance. Then whichever distance comes as minimum, I'll be writing here. And which center it refers to, I'll be writing that here. It refers to center 1. So I'll be writing 1. Okay. The same process is repeated for point number 2. The distance of point 2 is found from C1, that is written here, from C2, that is written here, from C3, that is written here. Again I will be finding the minimum. Okay, minimum refers to, minimum is this value, and that refers to 2. Likewise, I will be finding the distance of every point in this green table from this light purple center table, centers. Okay, so distance from C1 is written in this column, distance of every point from C2 is written in this column, distance of every point here from C3 is written in this column. Then we find the minimum, and as soon I get the minimum, I get the centroid from which this is minimum, right? And then I will be getting different clusters depending upon the nearness to the centroid. Okay, so I have the first point in cluster 1 because that point is near to center 1. Second point is in cluster 2. Third point is in cluster 3 because the second point is near to centroid 2, and third point is near to centroid 3, and so on. I'll go on getting the centers, centroids for each of the point, right? So here you see some centroid. This point number 61, it is close to centroid 2, and point number 62 is close to centroid 1. Point number 63 close to centroid 1 again. Point number 64 close to centroid 3. This way I got the centroid from which all this point number 1 to 200 are near. Okay, and that those who belong to those who are near, those points which are near to 1 will form the element constituent of cluster 1. Those points which are near to centroid 2 will form the constituent of cluster 2, and likewise the points which are near to centroid 3 will form the constituent of centroid 3. This is first process. Okay, then once I get the centroids, what I'll be doing, I'll be finding the average of the centroids. All right, see, I have got the average of the centroid. How do I do that? Now which like for example point number like in first centroid, you have number of points. Like here, 192 is the member of centroid 1, 199 is the member of centroid 1, cluster 1, 200 point is the member of cluster 3, and so on. 196 is a member of cluster 2. So what we will be doing, I'll be collecting all the points which belong to cluster 1 from here. from this green table, right? Okay, go back to green table. So you take the point number 198 and 199 and all the points which belong to cluster 1. You take the average of each of the column of all the points which belong to cluster number 1, right? So I'll be getting 10 averages, right? All the points which belong to cluster number 1, you collect them, you filter out all the records with cluster number 1, right? So from that green table, I will be getting something like 40, 50, 60, 70 records, whichever are filtered as belonging to cluster number 1, right? So I'll be taking the average from that information in the green table, all right? And I'll be now getting the new centroid. Okay, this is the new centroid. Again, there will be 10 values here. Then what I'll new centroid 1 for cluster number 1 average by taking by taking the average of all the values of the points which belong to cluster 2 from the green table. I'll be getting the average for all the points as far as 10 columns are concerned which belong to cluster 2. Likewise, for cluster 3, I'll be getting the new centroid. Okay, by filtering all the records which have fallen in cluster 3. Average is not to be taken from here because there are just 3 columns and this is distance. Average is taken from the green table, right? Now I have got new centroid. So what I'll be doing, I will be finding out the change in the centroid. Okay, you had earlier centroid C1. Okay, like here this is C1, C2 and C3. Okay, one coordinate means x coordinate of centroid C1, C2 and C3. Likewise, you have y coordinate, z coordinate, a coordinate, ab coordinate. All 10 coordinates will be there, and I have newly found the centroid here. Right? I have gone to away. I have got new centroid by averaging the different 3 clusters I have obtained. Now this is going to be new centroid. And then I have to find the distance between earlier centroid and new centroid. C1, C1, how much is the distance as far as all the coordinates of C1 are concerned, old and new. C2 are concerned, old and new. C3 are concerned, old and new. This is the difference between the new coordinate and the earlier coordinate. So this difference, you have to continue doing this process till you get all these differences converted to 0, right? Right? Then you will iterate the thing again. Now, instead of taking the distance of all the points in green table from earlier purple centroids, you will be taking the distance of all the points in green table from this table, new centroid. Okay, this mm, minus that x3 value was there. This value minus first row in the green table, first row, first column in the green table, then this value minus first row, second column of the green table, and so on up till first row, 10th column of the green table minus this square, and sum all that. That will be the distance here. Likewise, C2, when for getting the distance of x2 from C2, first row in the green table from second centroid, right? Now you will do the same process, but with this as the centroid, C2 as the centroid. Here also you'll do the same process with C3 as the centroid. In all the cases, your first record is going to be the same, only centroids are changing. When you will be doing the thing for second point, you will be referring to second point from the green table, right? And taking C2 as centroid, you will be finding minimum, and you will be declaring that column centroid number for which the minimum value is found out at the centroid. So again, same thing you will be doing, but with this value as centroid, right? Again, this calculations you will be doing for 200 times, right? Then once again you will be finding the centroids for cluster 1, for cluster 2, and for cluster 3, and with reference to earlier centroid you will be finding the distances of new centroid, and that those distances are supposed to be lesser than earlier one, and they will tend towards 0. So this process you keep on repeating till all these values come equal to 0 or very close to 0. Okay, so this is how you will be doing the k-means clustering in Excel sheet. You can write the program in Python which will be accessing this sheet, and it will run the same process, and you will get the centroid. You will get the clusters. Okay, so finally I am going to show you the clusters. Okay, when you want to write this in the theory, what you will be doing, you first will be showing how the data was collected, then how it was mapped, and then this algorithm in short of k means clustering. Okay, you don't explain Excel sheet in detail completely in exam, right? Now that you have got, you will iterate the process of changing the cluster centers till there is no change in the cluster center. Okay, you will continue to do that. Okay, and finally I get the clusters, right? Let's come back to. All right. Um, Open Urban Byte Segmentation Dataset, CSV. When you will be dealing with some other dataset, you will be mentioning the name of that dataset. CSV means comma separated value, right? You better convert this CSV file to XLSX file, right? Because in that case you will be able to use more facilities of Excel, right? Then review the variable columns, like age, income. All these columns have numerical values. Hmm. There are 10 columns. Then identify numeric variables, right? We have already written the numerical variables. These are the ones you will use for clustering. This is means you take the Excel sheet of your concern, then find out the numerical columns, okay, but study the complete information well before you proceed ahead and separate out numerical columns, right? Then standardize the variable. There are two methods of standardization. One is convert all the values to Z value. How do you get Z value? That is written here in the transparency. Z value is Z is x minus mu by sigma. X minus mu by sigma. So x is the value with which you are concerned. Mu is the average and sigma is the standard deviation. So for every column which you have separated as numeric variables, you will be finding mu and sigma, and then you will be recreating the new table from this table by using the formula the cell value minus mu, that is average of the column divided by standard deviation of the column. What will this do? It will convert all the values in the table between minus 3 or minus 4 to plus 4. Okay, there will be rare occasion in your table, new table which you will be getting, to have value like minus 4, minus 3, or on the another extreme 3 or 4, because they stand for extremity, right? So irrespective of whether your data is in tens or hundreds or thousands or 10,000, all your values will get converted to value between minus 3 or minus 4 to plus 4. Okay, so values are standardized. When you collect the data from the environment or data of your interest, it may range from anything to any other thing, but this exercise which we will be doing will be converting the data to lie between a very small range. The another thing, another formula which I normally use is to convert the value, uh, whatever value you have in the table, to lie between 0 to 1. How do we do that? What is the formula? X minus minimum upon maximum minus minimum. Okay, we have used this formula. You can equally use this, but there were many computations, so I avoided this because I was required to calculate average for each of the column and standard deviation for each of the column. That I avoided. I was getting minimum and maximum for each of the column. I worked ahead with that and converted the data which I had collected to collected the data to lie between 0 and 1. Okay, so you do this for all numeric variables, then run clustering in Excel, or you may run your Python code which will be taking the information from Excel sheet. All right. So Excel doesn't have built-in clustering add-in, or there is no functionality of for clustering. You have to write in the Excel sheet by means of the formula, okay, or by means of some toolkit like basic Excel functions in worksheet. You By using that you may get clustering, or you may add data analysis tool pack which contain k-mean and clustering by means of solver. Install analysis tool pack. Okay, he has shown the path by which analysis tool pack, which consists of k-mean clustering, is done, right? But I will advise you to know the things better by using Excel formula yourself. And once you become conversant with using Excel formula for getting k-mean clustering, then what you may do is to get the Python program which will be referring to the Excel sheet and doing uh, analyzing or processing the data to get you the clusters, right? Now I have got the clusters. I would like to show you all those clusters. No, this is not. All right. So cluster one, here you see the first point, first record, fourth record, fifth record, sixth record, along with this complete information. is written here. All protein column information. This is done programmatically. So in this first cluster, out of 200, I have 69 records, right? Just a minute. I have 69 records in the first cluster, right? By K means we have by running the process again and again, finding new centroids and finding the near points near to the centroid and clustering them again, finding the center of the new cluster formed, and this way moving the process ahead has got you different clusters, and we have separated those clusters for further analysis, right? So in the first cluster I have 61 header row. If I leave that out, there are 59 records. In cluster 2, how much do I have? In cluster 2 I have 62 records. 62 record means what? 61, because top one row doesn't have information, it has header. Okay, 61 row, 61 records in cluster 2. And what about cluster 3? In cluster 3, how many do I have? 81 means 80 actually. So in first cluster I have 59, second cluster I have 61, and in third cluster I have 80, totaling to 200. Okay, so I have been able to separate the information, clubbed information, combined information of 200 rows in three groups. You may think of forming four groups. Procedure is the same. Okay, you may think of forming four groups. So I hope you have understood how the k-mean clustering is done. Okay. Then run clustering algorithm. You have run it. You have got the clusters, right? Then now segmentation, right? By observing and studying the clusters, some clues will be given. Earlier the data was mixed. Then by using k-mean clustering algorithm, we have separated the data in three groups. You could have separated the data in four groups. And by studying the data, different clusters, we have come to a conclusion that we will be forming, we have to nomenclate these three groups separately. So in first observation, it is observed that first group, I have taken the averages of each of the clusters, and I come to a conclusion that the first group should be for young professionals, because I have found out that the average, I'll show you the Excel sheet once again. All right. Just a minute. Here it is. So what I may do, for as per as first cluster is concerned, I will start finding the average, like is equal to average. So I will find the average for all the columns, all the numeric columns in the Excel sheet I am having, right? Is this that? No, no, this is not that. Hmm. So for all the numeric columns in each of the cluster, I'll be finding the average, like for age, income, then health, consciousness. For cluster number one, I have the cluster number two. I have copied all the elements, all the constituents, all the persons from belonging to cluster two, or which I have pushed them to cluster two in the second worksheet labeled as cluster two. Okay, here also of the age I have found the average, and I will be finding the average for every numerical column, because I can find the average only for numerical column. Okay, for cluster 3 also I have did it, and all this average information I have in the fourth worksheet. Like, for example, cluster age information is here for cluster 1, cluster 2, and cluster 3. Age, income, health consciousness, time sensitivity, and so on and so forth. Right, for all the 10 numeric columns, I have the averages, right? This is the basis. I'm trying to do the segmentation from the clustering. Okay, now that I have gathered the data, separated the data which was 200 in number into some numbers. Like I am having 59 persons in group number 1, cluster 1, 61% in cluster 2, and 80% in cluster 3. Okay, total is coming out to be 200. That is 29.5% is in cluster 1, 30.5% is in cluster 2. Both the clusters are of comparable size, and 40% are there in cluster 3. Now, how I'll be doing the segmentation? I have to consider one segment of a particular type, and that kind of service I'll be providing to each segment will be different from another. Not too different, but I'll be focusing on specific thing. Yeah, as far as cluster one is concerned, specific other things as far as cluster two is concerned, and so on. Okay, so I have to give the labels to this clusters. So once again, going on to right labels in the sense young professionals. So for some time you will have to study the data to arrive at the labels to be given to the clusters, and that will be joining the segmentation with the clusterization, right? So first group, if you look at, you will come to know that the average age is less and they are health conscious like the youngsters are, right? And there are few other characteristics which have not been displayed in this worksheet. Only numerical information is there, but you refer to non-numerical information, then you will be convinced that I can give the first cluster as the name young professionals. Okay. The major characteristic for calling it as young professional is age is between something like 25 to 31, 32, so on. They are health conscious, maximum health conscious person. Okay. Now another group, family, the group with family, the average age is 35. Then the income is medium, and they give maximum importance to convenience like the family persons do, right? Because they go to a restaurant with their kids and so on, wife, many other members. So this group is called a busy family. Okay. And third group is by looking at the data and separating it from other on the basis of other criteria. This group, their spending is average spending is less on the lesser side, and they want to value for money price. They are sensitive to price. Okay. And if the price is more, they change the restaurant, right? So these people are value seekers, right? So we have got three groups. Okay, if you would have decided to have four clusters, five clusters, you would have got five segments. Okay, the question now comes: how many segments I can have? What is optimum number of segments I can think of? Right. So you for that the analysis of the kind mm, called as starting from one cluster, means one cluster center, and distance from all the distance of all the point from only one cluster center, or everything will come in one cluster. If there are two, then from two centers you will be finding the distance, Euclidean distance of all the records, and whichever are closer to first center will be part of first cluster, and closer to another center will be part of second cluster, right? Then what you are going to do is you will be taking the average of all the elements in the cluster 1 for all the attributes of cluster 1, and same thing you will be doing for cluster 2, and that will give you the new centers, and you will keep on repeating the process again, finding the again modifying the cluster based upon the distance from new centers. For whichever point the distance is lesser from C1, they will be member of cluster 1, and the lesser from C2, they will be the member of cluster 2. Okay, then for 3, then for 4, 5, 6, 7, you will go on doing this way. Now you will find that the total of the distance, goes on decreasing as you go on increasing the number of clusters. For one, the distance total of the distance of all the points from one cluster center will be maximum. If you take two cluster centers, that means you form two clusters. The total of the distance from of all the points from first cluster center, or not all the points, not all, total of the distance of the point belonging to first cluster, from C1 plus total of the distance of all the points belonging to cluster 2 from C2, this will come less. For 3 again less, for 4 again less, and at some point it will be lesser, whereafter it will go on decreasing very fast. Okay, so that point from which the total of the distance start decreasing very fast is called as elbow point, and that is the number of cluster you should make. Okay, you may refer some elbow point for optimum number of clusters, right? Anyway, then now that we have labeled the different clusters by the attributes which are favorable for that name, then we'll be coming to choose the target segment, that is better explained in the next transparency, right? Coming on to next one. So urban byte must choose which segment to target for expansion. Okay, management consider market attractiveness. That is, how much is the growth, how much is the profitability, and how is the alignment with trend, etc. And the competitive position means its own fitness for the strength and differentiation potential, right? Using the segment attractiveness versus competitive fit matrix, urban byte evaluates that young professionals, they are attractive because they are large, reasonably large, growing. Their frequency of coming to restaurant is high. They are strong fit for urban bites is health consciousness, and they like customizable meals. Okay, so that is more attractive segment for the urban bites. And then another is busy families. This is attractive but competitive. Okay, many are delivery focused. They don't come to restaurant. They get the delivery at home. So many delivery focused player already serving, right, requires operational excellence, right? Then value seekers. They are large in size but low profitability because there is high churn, means they will be using certain restaurant for 1 or 2 times, and second next time they will be visiting another restaurant, right? That is a weak fit in urban bites premium positioning, right? Then decision. Urban Byte decides to prioritize a young professional as primary target, with a busy families as secondary target, and value seekers, they have decided not to work for the value seekers because their churn ratio is higher, and their average spending is lesser, and they want more value for less money, and soon they don't get it, they will leave that restaurant. So targeting strategy is young professionals. For young professionals, give them fresh, customizable bowls or healthy snack. Then for ordering, have a good app based, because they frequently use app, right? And promotion, because they are health conscious, um, tie in with the fitness app. Social media influencers you may frequently use. Then as far as busy families are concerned, uh, uh, advertise or provide family meal packs, kids menus, so that kids will be pulling their elders toward that restaurant. uh, Emphasize on delivery plus subscriptions. As far as promotion is concerned, convenience focused campaign, dinner solved message. Okay, so this is how segmentation analytics goes. We have utilized segmentation analytics here just to separate out the information into multiple groups, and the later part was still subjective. Little bit of analytics is coming to the targeting part of it. AI can do better, much better, in the segmentation area. Okay, so thank you. This is about how the clustering, K-means clustering can be used for the market segmentation, customer segmentation. Okay, so these two topics which we have seen will help you to make yourself think of many analytics algorithms in marketing to make up the course like marketing analytics, right? So thank you.